everyone, we're back with the unit on systems of equations. So let's look at the description of what this is first. A system of equations exists when two or more equations overlap at a specific point, infinite points, or no points at all. So we're going to do a little bit of an overview first. In this section, we'll look at two different ways to solve a system of equations. The first is by elimination, and the second is by graphing. So we'll look at maybe which one would be better depending on the situation. The observations you make about the systems of equations will help you identify what type of solutions you are looking at or what you have given to you. Below are three different types of solutions you'll encounter in this class. The first one is one solution. And you can see we have two linear equations, and they have exactly one point at which they cross. The intersection point for these two lines would be 4, -1. That is the solution to that system of equations, just by looking at the graph. So the lines intersect, they have one point in common, and there is one solution to the system. We call these types of equations consistent or independent equations, systems of equations. This next one has parallel lines, and the lines have exactly the same slope. We can check this by looking at the rise and the run. It looks like it's right at a rise of 2 and a run of 2, 4, 5. So let's check to see if that's about what we have in the second graph. And it does indeed look like the rise is 2 and the run is 5. So since these two graphs have exactly the same slope, they're never going to lean toward each other and touch. In fact, they will infinitely parallel each other and never have a solution. So we say that these have no solution, the lines are parallel, and they have no point in common. We call this an inconsistent system, or we will also, if we ask you whether this system of equations exists, you would say DNE. This stands for does not exist. This last example is infinitely many solutions, and even though you can't see it because of it looks like there's only one line there, there are actually two lines that are perfectly overlapping each other. They are existing in the exact same space. So we say that this has infinitely many solutions because any place we pick on this line will also be a point on the other line. And it doesn't matter where, it will create a system with infinitely many solutions where the two lines overlap. So we would call this one a consistent, dependent system of equations. At this point, I'd love for you to pause the video or stop the video, but before you move on to the next video, think about how you're going to tell these three different types of graphs apart from each other. It's going to be particularly helpful for you to be able to identify when a system is one solution, no solutions, or infinitely many solutions. And so you'll want to take a few minutes to write down any notes, any observations, anything that you've noticed from these three examples. It would also be a perfect time for you to think about what you still wonder about these three different types of solutions.